Alright, we move on now to the second part, and this is where you compare statements. So I'm going to do the first four in the book, and basically all you're going to be doing is just sort of following along real quick as I show you some of the terminology. In this case, all you do is you put these into, you have two statements. What we would usually do is just leave a blank space between our two statements. You could always, probably do something if, let's see, you could do something like that, which would help to distinguish, just sort of merge the cells. You did here. You could go down on all these and just merge the cells. That way you can see where the break is. And you just go through and do this. In this case, you have two variables, P and Q, all the way across. And so you would say, okay, so I have two variables. So I'm going to just go ahead and do a truth table, just like I would anything. Highlight the main operator. And the only thing is you need to make sure that if P is true, true, false, false in this one, it needs to be true, true, false, false in this one. This is going to allow us to compare, with the same variables, how do these two statements compare up. And in this case, it's true, false, false, false. So what's going to happen is you highlight this, and we can then look at this and say, well, how do these compare? Well, what we would find is that on one line, they're both true, and on one line, they're both false. So they could be the exact same all the way across, but they're not. On one line, they're true, and one line, they're false. So what we do is we would label this one what we would call consistent. And what that means is when comparing two statements, at least one line has a truth value of true, but they are not logically equivalent, meaning they're not the exact same all the way across, but on at least one line they are both true. A truth value of true for, we'll say, for both statements, but they are not logically equivalent, meaning they're not the same all the way across. Let's go ahead and do this one. In this case, once again, 4 lines, there's only P and Q. And actually, just sort of as a fun note, in logic we usually use P's and Q's. And sometimes some people have heard people say, mind your P's and Q's. It's actually a reference to logic saying, be careful, where your P's are and where your Q's are. Don't get this one being true and the other one being false. So if this one's true here on this line, you need to make sure it's true on this line. Don't go true, true, false, false, and then when you come over here, start over again, and then Q and P have different truth values. You need to make sure that you go true, true, false, false, that they match across the line. If that makes sense. So what you're going to do is just go ahead and do this truth table, false, false, true, true, and then highlight this so you don't look back at it. Just, highlight it in a color that you know is not to be looked at anymore. And then do the same thing here, false, true, true. And then highlight this so you don't look back at it. And then what you're going to do is go ahead and do the next step. So false, horseshoe, true is true. False, horseshoe, true is false, horseshoe, false is true. False, horseshoe, true is true. True, horseshoe, false is false. And true, horseshoe, true is true. And then you come over here, and true, horseshoe, true is true. False, horseshoe, true is true. True, horseshoe, false is false. And that one's true. And so then the final one, always remember to highlight so you know what you're comparing. And what you're going to find is that in this case, the truth value is the exact same on the line 1, it's the exact same on line 2, it's the exact same on line 3, and it's the exact same on line 4. Which means these are what we call logically equivalent, which means that the truth value of two statements are the same on every single line. So we can go ahead and move on to the next one. In this case, true, triple bar, false. The only ones that's going to be true are where they're both the same. The other's going to be false. So we can just go ahead and highlight that. Don't have to mess with the other ones. In this case, we need to go ahead and, the tilde, so that's the minor variable, and then highlight this so you're not looking back at it. Remember, always do that, or mark it on your paper. And then true ampersand false is false. True ampersand true, or true dot true is true. False dot false is false, and false dot true is false. So highlight that as yellow. And so we're going to say, okay, true, false, false, true, false, false, true, false. Now they're not the exact opposite on every line, but there are no lines in which, but there's at least one line in which they're the same, and that is a line in which they're false. So what we call this is inconsistent, which means that when comparing two statements, they are both false on at least one line, but they are not, but there is no line in which they are both true, and they are not logically equivalent. So you need to make sure that's the case. They're not logically equivalent, but they're not logically contradictory, and so, but we find there's at least one line where they match. If they match and they're true, then we call it consistent. And if they match and they're false, we call it inconsistent. Now, the key here is any one line in which both true, we will go ahead and give it the label consistent. But if there's any line in which they compare and they're false, and there's no line in which they're true, we'll label it inconsistent. The reason we do this is it helps us in logic to know, to say, well, these aren't the same, but they're at least consistent. And sometimes that's important in philosophical arguments to know that, yeah, we're not talking about the same thing, but we're talking about things that aren't contradictory. And we're not talking about things that are inconsistent. Inconsistent would mean, the statements aren't contradicting each other, but they both can't be true at the same time. Consistent means they're not the same, they're not the opposite, but it is possible that in some world that the statements could both be true simultaneously. And sometimes this is important because sometimes when you're arguing with somebody, you might have somebody and they would say, well, you told me that there was a train on the track and you're still on time. And you'd say, well, that's not a problem. I mean, those statements are consistent with each other. I can still be on time and still get delayed by the train. I can tell you that I got up and I didn't have time for a shower, but still be clean, because I may not be in that dirty and really needed a shower. That sometimes people would say, well, it appears you're contradicting yourself, when in fact all you're doing is making two statements that can be true simultaneously. They can be consistent. Inconsistent, on the other hand, means you're not contradicting yourself, but there's no way that both statements can be true simultaneously. And so this is somewhat important. Logically equivalent means they're really saying the same thing, and logically contradictory means anytime that statement's true, the other one's always going to be false. So you're saying something that's always going to be opposite of each other. So G horseshoe H, once again, 4 lines. In this case, we're going to go true, false, true, true. And over here, we're going to go true, true, false, true. So in this case, we highlight this, and we highlight this one, and we then say, well, they're both true on one line, but they're not the same on this line, which means they're not logically equivalent, but they're not contradictory. They're not logically equivalent, but they're not contradictory, and they're at least true all across on one line, so we would label this consistent. Okay. Now the only other piece of terminology that we need, we learned consistent, inconsistent, and logically equivalent. Isn't that right? Did we get consistent, inconsistent? Is that all of them? I'm sorry. I'm trying to make sure. I'm trying to remember which all we did. We did inconsistent, we did logically equivalent, and we did consistent. The only other one we need to learn, and I'm not going to show it to you right now, is logically contradictory. You should be able to kind of follow this. And logically contradictory means that the truth value of two statements being compared is the exact opposite on every single line. Okay? And that's all there is to it.